Kia ora koutou, here's question 1E from this year's level 3 differentiation paper. So I think this is an excellence question, but I'm not 100% sure. It might be a merit question, but I think it's the hardest question out of question 1. So we're told that we've got P, which is a positive real constant, and we have to prove that y is equal to e to the p x squared does not have any points of inflection. And of course, we have to use calculus and show any derivatives that we need to find. So I guess the first thing to say is, what do we need for a point of inflection? Right? So for a point of inflection, we have to have the second derivative equaling 0. Now, it's not that if we have the second derivative equaling 0, we've definitely got a point of inflection. So if you think about the function y is equal to x to the power of 4, and if you're in my class, you will have seen this function a bit. That's basically a very, very steep parabola, and it's got a second derivative of 0, but it doesn't have a point of inflection, right? But if we want to find a point of inflection, we've got to have the second derivative of 0. So it's necessary, but it's not sufficient. So if we can show that there are no places where this is true, then we will have shown that there are no points of inflection. Okay, so all we've got to do is differentiate once and then differentiate again. So dy by dx is equal to e to the power of px squared times the derivative of this function, which is 2px. I'm going to write that out nicely. So 2px times e to the px squared, and that's just using the chain rule. To find the second derivative, we're going to use the chain rule and the product rule. So I'm not writing it out with u and v because I figure if you're watching this, you can probably do it without that. We've got the first function times the derivative of the second function, but remember, we've just found that up here. So it's 2px e to the px squared, and then we're going to go the other way around. So now it's the derivative of this one, which is 2p, times this function here, e to the px squared. So we need to show that that can't ever equal 0. So the first step is to clean it up. I'm going to take out a factor of, what am I taking out a factor of? E to the px squared, and here I've got 4p squared x squared plus 2p. Okay, so then the next step, we've got this here, and we can take another common factor out here. So we're going to have 2p times 2p x squared plus 1, so that's fully factorising this, times e to the px squared. And what we want to show is that that can't equal 0. So I'm going to do that in 3 steps. 2p is greater than 0, because we're told that p is greater than 0 and p is real. So that's that one done. The next factor, well, we know that 2p times x squared must be greater than 0, which means, well, sorry, must be greater than or equal to 0. But when we add 1 to it, we have 2p x squared plus 1 is greater than or equal to 1, which is greater than 0. And lastly, e to the power of anything is strictly greater than 0. Right? So what we've shown is that each of those factors is greater than 0. Since all 3 factors are greater than 0, the second derivative is greater than 0, and it's not equal to 0. So there are no, I'm really hammering this, right? But there are no solutions to the equation that the second derivative is equal to 0. So there are no points of inflection. So there you go, that's the first question done. I'm going to do the next 2 probably later on tonight when there aren't cooking noises coming from the kitchen right next to me. Thanks for watching.